In this video, we'll continue our discussion of ways to describe a frequency distribution, focusing on the difference between a cumulative percent and a percentile rank. To do that, we'll use this distribution of 50 quiz scores that range from 0 to 10. As you can see, 3 people have a score of 0, which is a cumulative frequency of 3. And 6 have a score of 1, which gives us a cumulative frequency now of 9. And 5 more have a score of 2, which gives us a cumulative frequency of 14. And so on and so on and so on, up to 5 with a score of 10 and a cumulative frequency of 50. Now, based on this pattern, the cumulative percent for a score of, say, 7 would be the cumulative frequency below the upper exact limit of 7, which is 35, divided by the sample size of 50, multiplied by 100%, or 70%. So the cumulative percent for a score of x is the percentage of cases in the distribution that occur below the corresponding upper exact limit of whatever x is. In contrast, the percentile rank for a score of x is the percentage of cases in the distribution that occur at or below a score of x. Now, it may sound like I just said the exact same thing, but there is a subtlety to what we mean by at or below a score of x. Instead of taking everybody below the upper exact limit, which would include everyone who scored x, we assume that if we could precisely measure with infinite accuracy and precision, we'd find that half of the people with a score of x are actually slightly higher than x, and half of the people with a score of x are actually slightly lower than x. So to factor that in, at or below a score of x only means half of the people who scored x. We can see it described mathematically here. The percentile rank for a score of x is the frequency below x plus 1/2 of the total number of people who actually scored x, all divided by the total sample size n. We then multiply that proportion by 100% in order to convert it to a percentile. Now, we previously determined that the cumulative percentage for a score of 7 was 70%. But the percentile rank would be the frequency below 7 plus half the frequency with a score of 7 divided by the total n of 50, all times 100%, or 32 plus 1/2 times 3, all divided by 50 times 100%, which is 33.5 divided by 50 times 100%, or 67%. Close to the cumulative percent of 70, but not exactly the same. Now, let's take a look at them another way in order to see just how and why they're slightly different. Notice that the cumulative percent can never be 0 because it's the frequency below the upper exact limit of a score. So even the lowest score won't have a cumulative percent of 0. It's all the scores in that with that value. On the other hand, at the maximum score, the cumulative percent will be 100% because all the scores fall below the upper exact limit of the maximum score. Similarly, the percentile rank for a score will never be 0 because even at the very lowest score, it's based on half of the number of cases with that value. But for the same reason, it can never be 100% either, because even at the maximum score, it only factors in half of the scores at that value. So as you can see, the values are often similar. And again, in our example, the cumulative percent for a score of 7 was 70%, and the percentile rank for a score of 7 was 67%. Fairly close. And in fact, they become closer in values as you have more and more groups and or smaller numbers within a group or interval. So that wraps up this discussion on frequency distributions. In statistics, we spend a lot of time working with frequency distributions, both real, like our examples here, and, as we'll see later on, theoretical distributions of more abstract things that we believe we would see under certain conditions. Okay? Bye for now.